Hey, how are you doing? Okay, so sorry, a little bit technical difficulties here. Well, as I was telling you, let me give you a warm welcome to another Job City Lunch and Learn event. So today's event is going to be really special, really interesting, and we're going to talk about the pros and cons and the differences and similarities about uh, really similar technologies. So, first of all, let me introduce myself. My name is Joseph. I'm from the Job City HR department, and I'm here today with a really special guest. So today we're going to have the help and the really helpful participation of Joao Ventura. He's like I personally consider him like a professional, like an expert into this topic. So here is Joao, and he will continue from now on. Hello, Joao. The spotlight it's all yours.
You're really kind saying I'm a specialist. So, well, we have some technical difficulties because my Mac is basically the most expensive paperweight I have ever bought. So, I'm gonna talk to you guys, look into the spreadsheet here, and in the meanwhile, I'm gonna do some minor slides updates. Basically, I am JP. It is the diminutive for Juan Pablo or Juan Pablo. I worked on Job City for at least almost 1 year and a half as a full stack developer. My expertise is backend development in Python and Node, and also Android development. If you are already watching the previous presentations of Lunch and Learn, they have a lot of interesting materials for not only for developers but also for CTOs or companies looking for developers. And previously, I have done a presentation regarding enterprise level development for backend APIs. So, doing just a minor uh, review about the so oh sorry a minor review about just 1 minute. Well, someone updated the presentation, no problem. So, doing a minor review related to what I have previously presented. Unfortunately, now it is not available. But if you guys wish to joke a little bit, I pushed my the whole code not only on GitHub to you take a look, but also on Google App Engine, so you can play with all the screens I am creating right now. Basically, it is a quick, dirty sample that combines Django RESTful framework and also some snippets on UI for backend development. Call it Open API. There's something similar, which is known as Blueprint and also Redoc, but OpenAPI goes can solve all the problems we have today, and also GraphQL. Why? Because I wished you guys were able to play and compare side by side how to implement an OpenAPI and also how to implement a GraphQL. Okay, so previews on the last Lunch and Learn I have presented. I did a 10,000 feet overview on several kinds of protocol of communication between clients and server. If you're really old and used to do programming like Unix TCP or pipelines, on the late 90s, something became quite popular, which is known as SOAP. And basically, it's a protocol that address communication using XML. But it was really verbohedric, and you have to write a lot of how do you say boilerplate code, and people start to think that it was a good idea instead of using XML and to use JSON files, and that's how REST standard was born. I'm going to go deeper on in a couple of minutes. Also, at the same time, something kind of like which is the JSON RPC also appeared, and later do some drawbacks on the late 10,010, 10,013 GraphQL and gRPC appeared. gRPC is quite popular inside Google, and GraphQL was created by Facebook. And oh, wrong computer. Uh, some more details about this. If you are interested in watching the previous presentation, you can just access the QR code with the link on the previous presentation, or just type the URL right down here. And I did some scaffolding, or let's say best practice for regarding about how to do or not to do a RESTful API. If you were handling really high standards of quality like industry or financial sector like PCI DSS, healthcare like HL7 or SNOMED, you have a standard way and really well defined by industry practice of how to code those APIs. And I said that I was supposed to do a presentation related to GraphQL and protocol buffers in the future. And someone asked me to do this presentation for today, and I'm happy to do this demo for you guys. So a 10,000 feet overview. The internet is no different from any kind of I/O device, like a memory, a disk, a USB driver, whatever. And if you are familiar with Unix programming, it's no different from a read, seek, delete, and write operations. So these are the basic operations you have to do in any kind of memory, and the network is no different from this. This is an acronym of CRUD or CRUD, and the the trick on REST APIs is if you represent the resources on your database or on your backend as routes. So imagine you have um, a pet store and you have to organize your routes as resources. So you have a pet and an ID, a pet and an owner name, whatever, and you can, instead of manually coding the name of the methods for get, read, whatever, you use the HTTP protocols to perform the operations, and those protocols are really well known: the get, put, and delete. You also have patch. The difference is patch allows you to update only a piece of your resource, and post you have and put you have to repost your whole payload again. Okay, and as I said before, it's an acronym for representational state transfer, and it's really hard to speak this in English. And basically, it's a really big payload. You can organize your document. Here is something I got from the Pet Store API, which is an open project related to OpenAPI, and you can find this on GitHub. And the resource is organized as a JSON file, and you have an ID, links to other resources that it may point, the type for this serialization, and data. This is a really high standard example I'm giving you here because it's quite how do you say, compliant to a HATOAS. I don't know how to say this in English. And basically, you can not only access the resource, but do introspection in runtime. So if I don't know how I do a pagination and I have to jump for 10 pages forward, 10 pages backward, or access the detail about any species, whatever, I can get the URL and discover the data in runtime. This is something, unfortunately, we discovered really late when we are becoming backend developers, because we tend to read the backend manual only until page 2. So when we need these resources, we have a lot of code written, and it is quite a headache to do modification on our code to insert these features. But if you are starting, if you have watched the previous presentation and you're writing this presentation right now, there's a quite Ctrl-C, Ctrl-V way of doing this instead of doing manually. You can take advantage of frameworks that do this for you. Okay, so I remember this as yesterday because I was working on a company that was supposed to do a refactor of a web application in PhoneGap to Android native, and it was around 2003. We were running everything on Google App Engine, and what was the problem? Mobile is something that was starting, so everybody had the mindset to code for full stack. So you have a really big application like Rails or Django with everything integrated. and nobody will have the mindset of splitting only the backend, only the data operations from the UI. I think not even React exists by the time, and we were writing everything in Angular 1. And what was the problem? If you are not, if you're from US, you're familiar with GMAT or uh, SAT, which is a test that college and undergraduates perform to go into the university. If you are not from US, uh, maybe you know TOEFL or IELTS. So it was basically a multiple alternative tests that you apply for the students. The company was working was refactoring something similar. We say in Brazil ENEM. It's the national evaluation for the high school students. And when we were downloading the payload, if you were connected to the internet, like in your home using a cable connection, it wasn't a problem. But by 2013, the mobile carrier plans for data were really, really expensive. So downloading a JSON file of 12 megabytes or 4 megabytes only to get a name would basically burn your data platform. So that's and this was a problem that Facebook was suffering a lot because they were exploding on the mobile market with the mobile application. So it was not only their pain, but a universal pain for mobile apps, and that's how GraphQL appeared. And what is the one of the amazing needs of the GraphQL, amazing features of the GraphQL? Uh, Instead of thinking the resources in terms of routes, like the whole route, or in terms of methods, name it after the operation, you kind of think more like the way we need the data, which is a graph with relations. So, uh, so if you think that instead of downloading the whole test, the only thing I needed was the number of the test, short description, and then when I click, I jump into the tests. I It would be possible to only pick those data and do the network operation. So instead of burning 12 megabytes, I would burn only 4K or even less. So this problem I'm telling you is something that is named overfetching and underfetching, and which mean exactly download the superfluous data, and the underfetching is on the opposite direction. Uh, when you think on a REST application, imagine if you had to do a lot of requests to compose the data. So taking the previous example, like the pet store, I need the pet store, the pet name, the owner name, and how do you say? I need to adopt a dog or a cat, and I need someone who is taking care of this. So I need to do three independent network operations and then gather the data. So what is the consequence of this? I have to manually handle this complexity on my client or on this microservice that is consuming this API. And basically, we're delegating the complexity and the distributed application consistency to the client. And remember, uh, think hurts, especially when you have to when you are wishing to provide your API to a lot of developers who don't have the expertise of neither the backend or the mobile applications or even a web application. So this is called the underfetching. So I need to do a lot of small a lot of requests to compose the data because I don't have all the data on a single request. And this is going to happen especially if you are being uh, HATOAS compliant, because the whole idea is you don't want to your routes represent your complex SQL queries. It's going to be more clear when I run the example for you. Okay, so remember the previous slide I was showing you that I have a lot of data? That's how the gibberish was telling you right now. So the GraphQL is going to, instead of organizing the API in terms of operations like on the HTTP methods, you have the basically two kind of operations: query and mutations. So the HTTP method doesn't define the operation. What define is some JSON, some string file you send on your post, which tells the server if you are reading or if you are mutating data. So the mutation can be a put, a patch, or a post, and a query, basically, it's reading the data. And as I mentioned before, um, the REST standard doesn't define how much data you have to download. So this is something that is defined on the server side, not on the client side. So the client doesn't have the liberty to choose how much data it wants to download. And on the GraphQL, the arrow points on the opposite direction. So who defines how much data uh, it must be downloaded is the client. And you the protocol protects the developer from doing a mess because it's not possible to download everything. You are forced to specify what to download, and this is something that let's say the language works for you. The mindset is no different from Java and C++ when you're considering dynamic allocation. Is instead of handling the pointers manually, the framework is doing this for you. So instead of doing the field selection manually on the in code level on the backend side, the language magically does this for you. Okay. So again, now I'm gonna do some minor comparisons between both of them. So what is the con? It's a little bit of a lie. The RESTful, if we're doing the RESTful development without any kind of deeper knowledge, there's a high chance of you do the overfetching. You may solve the field selection the right way using the frameworks, but there's a problem. I think all the features and the problems I'm telling right now, I learned the worst way possible, which was on the uh, basically smashing my head on the wall for several years, and after many months to discover how not only how to solve this problem but how to make the framework work for us. But the overfetching, long story short, is not something that come out of the box for you, and also it's not solved by the framework. Sorry, and it doesn't solve the underfetching resource as well. And okay, so as I just mentioned, it you delegate the responsibility to the developer. So you basically requires seniority, and it's a lot of knowledge that it's hard to pass through junior developers, for example. And if you are eager to check a really excellent examples of how to write a REST API, take a look at the API of Zalando. So they have all the greatest practices on pagination and everything else, and this is on the a payload example I just mentioned before. And another problem that is also solvable, but I I forgot how hard this was if you have to do this from zero, is the documentation. The framework can do the documentation for you, but it's not so automatic. So you have to choose which one you have to use. And long story short, I did the comparison. I have to code for you guys both the GraphQL Open API and the REST API, and no doubt the documentation of the GraphQL was much easier because it's also forced by the language. I don't have to keep thinking about this over and over. And okay, so the pros of the GraphQL as mentioned before, uh, it is a strong typed grammar, so you have to specify the types of which you are uh, dumping from the backend. So if you are used to any kind of strong typed language as C sharp, it doesn't make, or Java, it doesn't make a lot of sense for you. But if you are more of the on the Python or JavaScript world, you have to do this validation using a library like what is the name? Joy, Happy Joy, or using TypeScript or any pseudo stronger typed language that convert this. Python allow it to do this verification on, I think, after Python 3.6 or 3.4. Anyway, uh, but the cons, this is something that is really hidden on the specification of HTTP and REST documentation. By default, your browser is capable of doing the caching of the resources. So you don't have to code in your client side ways of not refetching the data. So you are able to take advantage of your own browser, for example, or your own Android application to don't do the refetch. But the GraphQL, in comparison to the HTTP protocol, it's quite new. It's a baby. So there's no well-defined policy to solve this problem. So you have to handle this uh, manually. Fortunately, there are libraries that provide this fetching, this cache and fetch for you. I particularly, I honestly like more Apollo GraphQL framework, not only for the backend but also for the client side, because it's capable of access your backend, grab your GraphQL schematic, and produce the client for iOS, JavaScript, so you can use for React, and also for Android. And as I mentioned on the previous presentation, the nice thing about this is you can do a whole integration on your CI/CD, and whenever you do a modification on a GraphQL, you automatically generate a client that is available to your client. Sorry, when I say client, I mean client library and client as software engineer perspective. So you don't have to tell your front-end developer, hey, I have just changed the API. Can you re-download this? Because once it is deployed on your CI/CD infrastructure, you can just use as a version as any library on the npm or any artifact on Maven. And this is amazing because you can bump or downgrade the version of the library without being blocked by the backend team. So, what is the con of the monolithic of the GraphQL solution? There's no silver bullets. So this is something that is quite tempting when you are refactor everything and just trying to map your API from REST, whatever, to GraphQL. So this also happened to one of the projects that was working. We have several, how do you say, microservices, and it didn't take too long before it became also spaghetti, because instead of trying to address each service as a query, what happened was it became spaghetti. So you had microservices that would turn it into a single monolithic on the GraphQL side. So again, keep in mind to always, let's say, not to think. And when I say this, is trying to make as much as possible this kind of the code generation automatic using the frameworks, because a lot of these organization will come out of the box for you. If you're interested on good ways of doing the management, not only of the microservices, but microservices, uh, sorry, micro GraphQL services, take a look at Apollo framework. There you can do this introspection of each microservice in the GraphQL into a single schema, and you don't have to handle this on the backend side manually and coding this. Also, you can join different sources of data, like not only a REST service, but any kind of data. And it was really interesting because on this application I mentioned you before, we were running everything in Firebase, and we had done along of 2 years, three whole backend migrations in Firebase, because we started using Parse, and later we had to move on Firebase 2 because Facebook was doing had sold Parse, and we had to do the phase out. And after 1 year and a half of coding that we had totally finished to do the Firebase migration, guess what happened? Google broke the whole API. So the GraphQL can work as a proxy to behind any kind of service. So if you have a legacy API like a bank API written in SOAP or several REST APIs, or even a spreadsheet in Google, and you need to provide this on a manner that is standard cross technologies, GraphQL, it's an amazing solution uh, because you really write less boilerplate code. And so, okay, I'm gonna basically show you here how to get your hand dirty on the right way using all this scaffolding stuff I have just mentioned you. So, and believe me, it works. But unfortunately, I discovered only 4 years later. Oh, oh. There is something that is called cookie cutter, and it literally is a cookie cutter, like the American cookies. You have a wireframe. If you have watched Squid Game, it's one of the games that you have to play in order not to die. You have to cut the candy in form of a star, a rainbow, or an umbrella. So cookie cutter is basically this. So if you have a bakery and you have to produce cookies on this with the same quality and size, you would have to do this using using the cutter. Otherwise, it would be hard to control the quality of the process. So this is basically what cookie cutter is meant for, for not only for Python, but for Django and several other frameworks. If you are from JavaScript world, there's something called Yoma. It has the same the features. So if you instead of coding manually and delegate to the developer or the architect the whole organization of your app, you can use the cookie cutter to do this for you. And the projects are really, really big. And one of the most interesting cookie cutters I found is not the Django cookie cutter, but Fast API and one from data science for creating Jupyter notebooks and machine learning projects. And both have a lot of contributors from Microsoft. And what I have just mentioned, Fast API, because Django, in my opinion, as an API is dying. Why? Because it's like Rails, it's meant to be a CMS, so you have a lot of things you won't be using to pure REST APIs. So it's basically like buying a big truck to deliver a letter. If you're starting from zero, I recommend using the Fast API instead of the Django REST. But why I'm using this? Just for the sake of the presentation. So basically, all you have to do is run these commands. You do a cookie cutter via GitHub, you download the template, and then you run your cookie cutter to create application. As simple as that. So then you just do the dependency installations, you create a virtual environment, you do the activation, start dependencies, migration, migrate, run server. And this is the standard documentation that Django REST framework provides to you, but it's really ugly. You can do some, you can put some pepper on your documentation using OpenAPI. And what is the interesting part about OpenAPI? Every OpenAPI specification should and can be downloaded as a YAML file or a JSON file. So the consequence, you can parse this to refactoring or to automatic code generation. All this documentation is generated automatically. So imagine for the sake of demonstration and for my log, my startup became a unicorn and I have to do a massive refactor. So I would have to split all the monolith as several microservices. And if I had the documentation defined this way, it was simpler to grab this OpenJSON file and split it and regenerate the server codes fastly. So it would be possible to get this specification and generate a Spring Boot or a Micronaut or .NET, whatever. Just pick the flavor of the framework you like and just do it. And this is something that happened to Instagram. Instagram was a monolith until it reached 50 million users and it was a Django application. And you can check the interviews with the founder, and he also discovered this too late. And then they migrated to a plethora of microservices. And Graphene is no different. Graphene is the standard implementation of GraphQL from Facebook to Django. You can run on Fast API, Flask, and Django, and the process is no different from this. So you download the cookie cutter, create your application, and you run install. So here I did two split applications, but what I did, and the code's available for you guys to download later, it's on the reference of the presentation. I merged it into a single application. Why? So you can literally compare side by side the difficulty of expressing everything using Django REST or using OpenAPI or using GraphQL. So, okay, the conclusions. Uh, what I can say. Uh, and it was funny to revisit these concepts on the last 2 days. It is much easier to express without a deep understanding of REST a service using pure GraphQL, and especially regarding documentation. And I almost gave you guys a spoiler on the beginning of the presentation, but I think that it took me, but this is something that is caused by the Django framework, 5 times more time to do the correct documentation in Django instead of GraphQL. And I can tell you this right now because I broke the application a couple hours ago, and it was amazingly fast to rewrite the graphene part without a deep understanding of Django. Um, so if you are obliged to obey some kind of compliance, like bank, like fintech, healthcare, I still recommend the resource and REST standard because the chances of finding something ready on any repository on GitHub or even a paid library are higher than GraphQL, and GraphQL is still under development. But for for mobile scenarios where you have to merge several technologies, I would totally go for GraphQL. Actually, and this is like more like a polite and unbiased opinion, but if I was starting a project from scratch right now, I would totally go for GraphQL. I'm going to run the dashboard here right now so you can have a view of how all each UI perspective varies. So feel free to doing questions in the meanwhile while I'm going to switch the screens. Okay, question, guys.
Yeah. Hi, JP. So I have a question over here from Juan Castro. He asks, are there any disadvantages of using GraphQL? Hi, did you hear me?
Yes, I'm changing to the dashboard in the meanwhile. Just hold on. Well, the as I mentioned before, if you are not as a disadvantage, but it's kind of magic when you start doing this. So it's quite easy. You start to make cyclic relations on the GraphQL payload. So if you have a pet that has an owner, that has a pet that has an owner, so GraphQL allows you to do this kind of mess. And once you discover the magic of doing this, not only inner joins of a single microservice, but several microservices, it's quite easy. You turn your GraphQL into a spaghetti, and this on a middle or long scenario is going to slow down your engineering team. So something that should be only a proxy or a facade to uh, coalesce all the services becomes a blocker. So this is something that the technology itself cannot block. And what else? And as I mentioned before, the problem is the cache. So if you're using a web browser, the web browser is capable of doing the cache for you. If you are using GraphQL, you have to use a library to do this. Apollo and Prisma offer libraries for not only on the website, but on the mobile side, but it's something that you have to use as a third party. There is no uh, out-of-the-box solution provided by the standard itself.
Okay, that's great. So yeah, that's that that's kind of frustrating when it gets like messy like that. So I can totally understand your point of view. So yeah, let's see if any other is there any other question? Are you preparing a screen to show us?
Sure. Uh, the codes. Where am I? Where am I? Okay,
Okay. So I kind of have a question too. In the
go.
meantime, uh, what would you think will be the main consideration to take in order to choose between GraphQL and REST, like the size of the payload, or maybe like the type of data that you're fetching? What will be like a solid criteria to choose between those?
There's no solid criteria, I think. First, it doesn't matter the technology. The slowest part of your development, it's always going to be the people. Like it doesn't matter. I have several friends that like to brush beats, and they keep discussing if Java or C Sharp or whatever language is the fastest. It doesn't matter if your HTTP request takes 1 millisecond, but your engineering team takes 2 months to deliver Hello World. So first thing first, if you have the seniority and changing the whole not only mindset but skills of the your team, it's gonna take some time. So go for REST. Uh, Again, if you're focusing on industry standards that you may sue if you're not compliant. So this is common on healthcare and fintech. Go for REST. But if you are joining several types of technologies, and I mean several, like Firebase, Redis, and REST, SOAP, whatever, and you need to provide a consistent API cross interfaces, GraphQL is a better choice because it is strongly opinionated related to the grammar. So you don't give the developer too much liberty to think, oh, should I name this method this way or that way? It doesn't matter because the operations are defined by the GraphQL grammar.
Oh, okay, I see. That's
So,
awesome. So I have another question here from Carlos Cornejo. He asks, have you had experience with indexing databases with GraphQL? What will be your comments there?
indexing databases, I don't get the question. Like
I,
because the indexing operation is, uh, as far as I know, use something that the ORM can handle, or you can do a DevOps configuration. So if you're consuming the query directly, it shouldn't affect the GraphQL, as far as I know.
okay. So, uh, have you done it before?
No, because it's quite rare uh, to, at least on the security standard, manual queries on the microservice side, because technically it would be exposing the query. So when you're doing this kind of tailor-made adjustment, this is something you do like on the Spring side when your query are taking too long. So uh, I think I understand the question now. Think this
Okay.
way: the graph, you can split totally the controller side from the handling side of the GraphQL, and this is what I'm going to show you guys. So,
Yeah.
any other question?
Not for now. You can go ahead.
Okay. Okay. Hey man, it worked. So this is the how do you say, the GitHub application. Maybe I change. I don't know if I'm going to keep this as a wider application because it doesn't have a lot of stuff to play around. Um, Originally, I was planning to do the whole past store present application, which is this one. Uh, Hold on, hold on, hold on. Uh, I was hoping to do for fun because from time to time we have to address some client on Job City, and they ask for a Node developer, a Spring developer, whatever. But basically, this is what the Android or the front-end developer should be capable to address, which is a well-documented and API. This is not a H2S3 level. Why? Because instead of using the HTTP methods to do the operations, it uses part of the route name, and this is a really bad practice to do the operations. So when you do a path creation or, sorry, image upload, you say image upload, and you should be capable of addressing this only by the method. So as I told you guys before, this is the specification. So it's not handling. Oh, sorry. If you can see here, there's a pet store swagger. So this is the specification. So you can parse this to generate your code. And going back to my application, I was hoping to implement everything on Pet Store for you, but it was taking really a lot of time. So I got a dummy weather application, and as I just mentioned some slides ago, I merged both GraphQL and the Django application into one. So here you have an app that it's basically the schema of the presentation, and this is how you see the application. And this access the model and do the whole magic for you, and it's going to be really surprising when I go on the next slide on the application itself. And this is the standard uh, Django App Application, because Django can be organized as Rails as sub-applications. So you have the schemas, serializer, the routes, which is the URL, and the views. If you're more familiar with MVC, the views, it doesn't make much sense on naming. The views are the controllers, and the URLs are the view. And the serializers were a pain to write. And everything is put together on the REST API. Uh, the REST API is an application, a Django application. So you can see here, I think it's too small for you. You can see the route which is pointing to. So, okay, Joseph, you're gonna pick. You want to the spoiler first or the REST first? I can.
We could go with the rest first.
Okay, so I'm going to open. I'm going to intentionally access a route that doesn't exist. Oh, wrong IP. So I'm running the application on debug mode, and you can see here, really small. Okay, you can see the routes that were specified on the application. If I was using a pure Django application, this is what I was supposed to see, and this is the ugly template. So you can go into the application and see the resources, but it's really ugly. So I can do, I have a form, I can do some minor tests, but I am fancy and I want something that is more eye candy. So I am using Swagger. So this is the same template I have shown you on the pet store, and voila, you have everything out of the box for you. So I have to diminish the fonts. There's a minor string formatting here error here, but you have the weather record in the singular and the plural. So, and this is something that is cool for the front-end developers. Remember when uh, every time you were really sad because the backend team was blocking the development on your side? So this way, the front-end team is capable of testing the API. So not only you have the documentation, but you have a shell here. You can do a tryout. So I don't remember if I have data on this. So I have an application payload. Where is? You can call using a curl, but it's empty. Yes. So whoop, we have a post. So let's try out. And oh, it's the memory is running out of my computer. So we can say I live in London. Oh boy. Okay, I'm not able to demonstrate here because I'm running the screen share and PyCharm, so it's eating the memory. But basically, you can do a tryout here and fill your screen with dummy data. So I'm going to open a share screen, and in the meanwhile, and this is the fancy guy. I added two routes, which is the GraphQL and GraphQL. GraphQL, in theory, should be using only one on debug or production, but the GraphQL is useful for doing this kind of experimentation, and this is really beautiful. It's ready. So, and this is something that is magic on the dashboard of the GraphQL, because remember all that uh, gibberish code that you have to read. If you haven't used the scaffolding, you would have to code that manually. But using the framework to create this for you, it kind of helps. But GraphQL way of doing stuff forces you to do. Uh, it's really slow. 1 minute. Forces you to self-documentate. Uh, how many minutes do you have? 8 minutes. I have to turn off something here. Ah, I know what is happening. The screen reader on Ubuntu is messing with me. Huh. So when you start to type anything it completes for you. So you have the mutation, which is the reading operation, and I forgot to tell you about subscription. If you are familiar with Firebase or WebSockets, GraphQL provides you a way to do a two-way binding and automatically sync data from your server to your application. So this is something you would have to do a polling to do the sync if you were using a pure REST application, or if you are on iOS or Android, you would have to send a push notification to the device and then get the data. Subscription just do this for you, but remember you have to do the adjustment to not fry your server, listen to too much useless content. So you have your query, and when you start typing again, just press Ctrl Tab and you see the data. And again, if I just try to run this, it is empty. I have to populate with some data. Just 1 minute. Post, tryouts. So hold on. Well, okay. Anyway, so here you would have to, you can, you are forced to specify what you want to download from your server. You cannot simply execute the whole application, execute the whole payload. And again, I haven't typed zero code to generate this. It just works. And this is the thing that most attracted me to GraphQL. So you can check your whole documentation on the console, and you can do nested queries like I can do a wider query, specify the ID, and instead of bringing the whole payload, I can bring only the temperatures, and I don't have to bring all the temperatures. I can get only the actual, and let's see here, the latitude, what I'm meant to download. So, oh, worked. And this, if you are handling fine-grained payloads, it gives you a really big help. And honestly, it was much simpler to implement than the whole backend Django REST. So if you're doing a startup product, honestly, go for GraphQL. But keep in mind, there's no silver bullet. You have to do this. You have to pay some attention. I'm gonna keep the application on my free tier of Graph Google App Engine, including the configuration of the deploy. The code is going to be available for you to play, and eventually, when I finish the whole implementation of the pet store, I'm gonna push over the application so you can do a comparative, which is the best solution for you. Any other question?
No, no more questions so far. I think we're good to go. Thanks a lot, JP. Thanks a lot for giving us this thorough like description and like point of view on which implementation or which technology. Well, it
Mm-hmm.
every technology is good, but uh, obviously some work best in different scenarios, right?
Yes.
So thanks a lot. Thanks a lot, guys. Thanks a lot for tuning in to the YouTube live for this Lunch and Learn. We'll keep you updated on next releases for different topics. Maybe we could have another topic.
I forgot to say, subscribe to the channel, click on the bell to receive notifications,
Exactly.
and also Joseph or Simon's going to not only write the previous presentation, but also the link to the code if you uh, is didn't want to watch the whole presentation but want to pick some examples. And feel free to do any question to us on the channel. And
Exactly.
See you.
Thanks a lot, guys. See you. Bye.